finding and applying inverse functions. So we've talked about an inverse function is when we take the output and the input and we switch them. So the x and the y coordinates, we reverse them. So it's the inverse. Finding an inverse function. So to find the inverse function, which we're going to call f to the negative first, so f negative 1 to the x. So f negative 1 of x of the linear function f of x. Remember, this is what we're used to seeing, and this is typically our y value. We talk about that as our y. First step, replace f of x with the y in the equation for f of x. So if we have an equation f of x, the f of x is going to come out, and we're going to put a y in its place. Step 2, interchange the x and the y in the equation. So we were doing that with our ordered pairs, switching the x and the y. We're going to solve the equation for y. So what was our old input is now going to become our output. And in step 4, we're going to replace the y with f negative 1 of x in the new equation. So let's put this to work. Find the inverse of the function. So we've got f of x equals negative 3x plus 27. So the first thing I'm going to do, I'm going to take this f of x out, and I'm going to replace it with a y. This just talks about the output. Y is also the output. Next, I'm going to solve this. Next, I'm going to switch my x and my y. So here comes my y out, and where goes the x is. X comes out and goes where the y is. So now my equation looks like x equals negative 3y plus 27. I'm going to solve this for y. So subtract 27, divide by negative 3. This ends up being negative 1/3 plus 9 equals y. And then the last step, we're going to take the y back out again and replace it with our f negative 1 of x is equal to negative 1/3 x plus 9. Okay, so there's just a few more steps to switch the x and the y when we're looking at an equation. So let's look at this in a real-world situation. Why would you want to do this? Carter sells paper supplies and makes a base salary of $2,200 each month. He also earns 5% commission on his total sales. So he's always going to earn that $2,200, but he's also going to make, on top of that, 5% of however much he sells. So if he's having a really good month and he's a really good salesperson, he's going to get 5% of a larger amount of sales. His check's going to be much larger. If he's not such a good salesperson, or he's not working so hard, or it's just a really bad month, he's going to earn 5% of a lower amount of sales, and he's not going to make as much that month. Encourages him to sell stuff. His total earnings, E of x, for the month in which he sells x dollars in total sales is E of x equals 2,200 plus 0.05 500ths x. This is just our 5% commission turned into a decimal. All right, let's find the inverse function of e negative 1 of x. Next, what do e negative 1 of x and x represent in the context of the new function? So we've switched the input and the output, so what do each of those mean? And then the last thing we'd like to do, find Carter's total sales for the last month of if his earnings for that month were $3,450. So one thing at a time. First, let's find the inverse function. Oh, and this should be B, C, and D. We have our E of x equals 2,200 plus 500ths x. So we're going to take out the E of x and replace that with y. Next, we're going to switch the x and the y in our equation. And now we're going to isolate the y variable here. So we do what we normally do here. And we end up with our y by itself. Now we take the y out and we replace it with f negative 1 of x. And that is equal to 20x minus 44,000. Next question. What do e negative 1 of x and x represent in the context of the new function? So before this, our x represented the dollars that he sells, and our e of x represented his total earnings. So we've switched those. So now x represents the total earning, and f, you'd be using an e there. Do I have my marker? I do. We should be using an e here, because we're calling it with an e. So e negative 1 of x is his total sales. So we've just taken the x, the input and the output, and we've switched them. We've created the inverse there. And the last question, find his total sales if we know his earnings. Now previously, this equation was really nice for his input to be his total sales and his output to be his earnings. We always love it when an equation, I put something in and out comes something, kind of our in-out boxes when we were in elementary school. But it's nice when it works that way, as opposed to plugging in an output and then having to rework the whole equation to find the input. We've already done all the work here. So we can now use his total earnings, what was previously our output, as an input. So again, I'm going to change this to E. So we're going to take our equation, which now uses what was the old output as our input, and I'm going to plug that in here for x, because x is now the total earnings. So I'm going to plug in his total earnings. I'm going to do my algebra. Remember, this is representative of my y, so it's just staying the same. It's not providing any, it's not working as a variable. And I come up with 25,000. So Carter's total sales last month were 25,000. I'm losing things all over the place here. Were $25,000. So he sold $25,000 worth of paper products. He earned 5% commission on that, along with his $2,200 regular that he earns, and to earn a total of $3,450. We were able to use this equation backwards of how we would have used the original function to find that previous input, as it were. Okay, so our inverse equations, we're going to take an equation, we're going to rework it so that the output is now the input is now the output. We know what each one of those represents now. We've just switched them as an inverse, and I can use that new function. If I know what the previous output was, I can use it as an input and figure out what my previous input would have been. So our inverse functions.